This is a little cheat sheet with all of the different types of numbers that are out there in the math world. Some of you guys already know about some of these. Some of you guys maybe need to kind of get up to speed on the vocab, but that's why I gave this to you, so that we could talk about this, so that you can use these words when you're talking about conditions or restrictions. What types of numbers are part of the inputs? What types of numbers are part of the outputs? Question? You are going to need to know these in order to use set builder notation. Oh, yeah, the top flap, we don't have anything else over there.
No, on the right. Yeah, that one. Yeah, you said that was continuous, but it doesn't include negatives.
Yeah, I mean, this can take on a lot of different formats. And that's the thing with informal notation, is that it's informal, so there's kind of some gray area in there. And that's exactly why we want set builder notation, because it lets us get more specific. Okay, these guys, so that we could talk about the different types of numbers that we want included. So this is what's going to give us the vocab to say, I want negative numbers. I want everything. I want only positive even numbers. Almost everything out there in the math world is what's called a real number. So pretty much all of the numbers that you guys would think of right now are all real numbers. And you might think, well, what's the point of that? But when you guys get down the road a little bit further, you're going to start learning about imaginary numbers. Yes, they are a thing in math. They do exist. We're not going to get into that right now, but just know that that's why we need to talk about real numbers, because there are things that don't fall under the real number umbrella. There are some very interesting mathematical things out there that you guys will learn about, I promise, but that's not the focus for today. There are some symbols that we can use in our restrictions. So instead of writing out real numbers, sometimes shorthand for that, and we're going to kind of fill this in, you'll see people just use an R. So R is the symbol for real numbers. So if you want to include everything, decimals, fractions, all those in-between values, negatives, positives, everything. If you want everything possible included, then you would say use real numbers, because that includes all the different types of numbers you can think of. These are all the different types of real numbers. You notice this is divided in half. One side is rational numbers. The other side is irrational. Here's the big difference between rational and irrational, and I'm going to add this in. A rational number is something that can be put into fraction form. So it might not actually be in fraction form, but you could put it in fraction form. So like 0.75, can I make that a fraction? Yeah, what's 0.75 as a fraction?
3/4.
Oh, so that's a rational number. Can you guys think of something that I cannot make a fraction? Pi, because pi doesn't follow a pattern. Pi is an irrational number. That's the difference between rational and irrational. Any decimal that follows a pattern can be written as a fraction. So basically, the irrational numbers are going to be things like pi that they don't follow a pattern. There's a bunch of square roots, too, that are also irrational. They're kind of like pi. Yeah. So like square root of 5, that doesn't follow a pattern. It's another irrational number. So that's the difference between the rational side and the irrational side. So rational can be written as a fraction. And I'm literally adding that in as a fraction. And irrational cannot be written as a fraction. So things like pi or square root of 5, those would be irrational numbers. Things like 3/4. How about 0.6767676767? Rational, because it follows a pattern. Any decimal that follows a pattern you can write as a fraction. Okay, now there are lots of different types of numbers that can be written as fractions. So within rational, we can kind of zoom this in a little bit. You guys, I know. Oh, and then there's a shortcut for real numbers, right? So R is a keyword or kind of a symbol that means real numbers. There's also symbols for all these other things. Symbol for irrational is an I for irrational. So as much as possible, these make sense. We're going to run into a problem with rational numbers, though. We can't use R because we're already using it for real numbers, right? So somebody along the lines decided that they were going to use a Q for rational numbers, and that's kind of becoming the common math notation. So we use Q for rational numbers. And again, we can't use R because R is already taken, real numbers. So we had to come up with something different, and it ended up being a Q. So that one you just have to remember because it's different. Okay, integers. They are a more precise group of rational numbers. You guys have worked with integers before. -2 is an integer. 5 is an integer. 1/2, not an integer. -2/3, not an integer. So what's an integer? Whole number, but it includes 0, and -7 is an integer. Yeah, negative. So integer refers to any positive or negative whole number. So I'm going to go like this. Positive or negative whole numbers. Okay? So integers are rational numbers, but there are some rational numbers that are not integers, right? So -3 is a rational number. 1/2, not an integer. So you see how we're kind of narrowing in on our groups here. Shortcut for integer, I'm going to run into a problem again. I already used I because that's what we use for irrational, right? So again, somebody decided that they were going to come up with a different letter that's become common notation. So the math symbol for an integer is a Z. So rational and integer, you just have to kind of remember because they don't start with the same letter. The rest of them do. Okay, now we're down to whole numbers and natural numbers. When you guys think whole numbers, what do you normally think?
Positive numbers.
Yeah, positive numbers, right? Here's the difference between whole numbers and natural numbers, and it's a really small difference. Whole numbers, 0, 1, 2, 3, 4, 5. Natural numbers, 1, 2, 3, 4, 5. Hey, we've seen that start at 0 versus start at 1 thing before, huh? Yeah. Now we have vocabulary to talk about that, don't we? So a whole number is going to be counting numbers starting at 0. So whole numbers are going to be 0, 1, 2, 3. Natural numbers are just going to be starting at 1. So natural numbers, a lot of people call counting numbers because when you think about counting, usually you start counting at 1. So counting numbers are natural numbers. Whole numbers include 0. And then we haven't used W yet, so that means the symbol for a whole number is a W. And we haven't used N yet, so that means the symbol for a natural number is N. So most of these are just the letters they start with. It's just the rational numbers and the integers that you have to just kind of memorize because they're different. The rest of them are pretty intuitive. So now we've got some vocabulary to talk about these things, right? Okay. I'm going to zoom this back out so we can come back over here. We've got these numbers in informal notation, right? A lot of times, if you think about making a graph or making a table, you guys use variables for the inputs and the outputs, right? Sometimes we'll use X and Y. If it represents something, we'll use something. So like if we're talking about costs, sometimes we'll use a C for cost. So this beginning part is just where you're going to put whatever variable name you're using to represent this. So let's see if we could turn this first one and see what it would look like in set builder notation. So I'm going to take my curly brackets and I'm going to give this a name. Let's pretend these are outputs. What variable do we like to use for outputs? Yeah, so I'm just going to say the set of all things Y. You can call it whatever you want. It's usually a variable name. Such that And now here's my conditions, and here's where this is going to come into play. If I'm doing 2, 4, 6, 8, what type of numbers am I using? The most precise group of numbers I'm using. Natural, yeah. So I want to say that my outputs are natural numbers. So here's how I would write that in notation. I would say all of the y values, and then the symbol that's a little tiny capital E. And what that means is they are elements of, or they are part of, natural numbers. Okay, so this is basically the math notation to say these are natural numbers. So the variable little e is an element of whatever type of number it is. Fancy math way of saying these are natural numbers. Maddie.
Can you have more than one? Like, can you have like n and z?
Usually you'll choose whatever the most precise one is. So if I'm choosing natural numbers, then I know that those natural numbers are also going to be part of rational numbers. So you want to choose whichever one most precisely describes it. Okay, and then I have another condition. So these are natural numbers, but natural numbers would be 1, 2, 3, 4, 5. Am I including all of the natural numbers? No. Which ones am I including? Evens, right? So I could write, sometimes set builder notation is a combination of symbols. We like to use symbols whenever possible. So when we're talking about what type of number it is, we use symbols. Sometimes we have to use words, though. If we need to say it's even, the best way to say that is going to be to use words, right? So, comma, because there's a second condition, I could say y is even. That's what my first set of numbers looks like in set builder notation. So if you read this out loud, you would say the set of, curly brackets, right? All values y, such that y is an element of natural numbers. That means y is a natural number. And y is even. We just very precisely described exactly what types of numbers to include there, right? That's how set builder notation works.